Alright guys, we are going over the Math 8 Chapter 1 test here. If you're watching this, it's probably because you need to do the Progressing to Mastery assignment in Schoology. So both, as of me recording this, both the Chapter 1 and Chapter 2 Progressing to Masteries are up there. That's because we're on remote and I don't know how to get paper back and forth between us, so that's going to be the best option that we have for now. So the first question, just talking about what do exponents do. Really brief reminder there. Positive is repeated multiplication, and negative, of course, is repeated division. So, right, we put that base value in the denominator, and then it is raised to that power. So that's repeated division then. So, for example, x to the negative 3 ends up with 1 over x to the third. Our exponent rules, when multiplying, we actually add the exponents. So that becomes m to the 7th. When dividing, we do the opposite. We actually subtract, so that becomes h to the 6th. On 4, 9 to the negative 2nd power. If Sarah was confused by this, we could just tell her, oh, it's dividing by 9 twice, or actually dividing by 81. 2/3 to the 3rd power, we're going to raise both the numerator and the denominator to the power separately. So 2 to the 3rd power is 8, and 3 to the 3rd power is 27. Same thing with 1/4 squared. 1 squared is 1. 1 raised to any power is still 1. 4 to the 2nd power is 16. 1/10 to the 4th power. 1 to the 4th power is still 1. 10 to the 4th power is 10,000. Moving on down. So the negatives is where people have a little bit of issues here. So negative 2 to the 4th power. So the negative is going to happen after we raise 2 to the 4th power. So that would be 2 to the 4th is 16. Then the opposite of that, your answer should be negative 16. You don't have to have the negative on the outside of parentheses. You could have it all together in one set of parentheses if you wanted, or just without parentheses if you so choose. Negative 2 to the 4th power, however, is a negative 4 times, right? A negative times itself 4 times total. So that's going to cancel out and become positive. So that actually becomes positive 16. And then 4 squared is also just positive 16. For 7 and 8, some people got caught up with thinking that there's a 1 here that we add with the 4. There is a 1 in front of the x to the 3rd, but that just multiplies, right? So 4 times 1 is 4. X to the 3rd times x to the 3rd is x to the 6th. Same thing over here with 14 and 7. We divide the 14 and the 7. Then we divide the w to the 6th and the w squared. And that's going to give us 2w to the 4th. We're going to start to throw more problems like this one at you where we use the same number kind of in 2 different ways. So if a square has a side length of 16 feet, to figure out its area, we're going to need to square that side length, becoming 256. But if a square's area is 16, we then need to take the square root of that, and that's going to give us 4. Again, if you want to talk about any of these questions, please come to Math Lab, AO, or Extensions. More than happy to review this stuff with you. This is just a really quick overview. So the opposite of the square root of 10 could be plus or minus negative 10. So really, there are tons of options here, because if we want to be technical, the square root of 10, or sorry, the square root of 100 has a positive and a negative answer. So these got kind of tricky to grade. So if you want to come and talk to me about any of these, that's totally fine. But that's like in 25, the square root technically is positive or negative. I accepted it if you just put the positive. For some of your papers, I probably put and question mark, just kind of pushing, you know, what else could work there. However, a negative number raised to a power only has one value. So it's either going to be negative or positive depending on the multiplication. So negative 8 squared is 64 and negative 1 squared is 1. Moving on to the back. Same rules with our fractions from the front about taking the numerator and denominator separately. So when we're using roots, we do the same thing. And when you have a decimal, you could write that as a fraction first. So we could write this as 16 hundredths and get to 4 tenths that way by square rooting 16 and square rooting 100. 0.5 squared we could write as 5 tenths, and then then square that value, and we would get 25 over 100. And 2/3 squared, we're going to square the 2 and square the 3 both separately. And try to get this focus back here. There we go. So our neighboring perfect square method is to say that radical 40 is an irrational number, right? It is not a perfect square, so we know it's going to fall between two perfect squares that neighbor it. So 36 and 49 are both perfect squares that we know. So 40 is in between them. So that question we just asked you for what is it in between. Number 12, we asked you to approximate it using that Rachel method, right? Named after a previous student of mine. So I'm sure there's a technical name for this method, but Rachel method's a better name in my opinion. So if we look at square root of 52, also an irrational number because it's not a perfect square, square root of 52 is going to fall between the square root of 49 and the square root of 64. So square root of 49 is 7, square root of 64 is 8. So we know it's going to be 7 and something else, like 7 and some remaining rational value, some fraction value. So we look at what's the distance between our two perfect squares. It is 15. And then how far has the non-perfect square gone through that distance? And that would be 3. So our numerator of 3/15 is 1/5. But if we actually square root 52, we get 7.2. So whether you want to say 3/15 simplifies to 2/10 or radical 52 is actually 7.2, we are awfully close just using that approximation method. 13 is pretty straightforward. Which of those is not a perfect square or comes out to be irrational? Volume of a cube would be length times width times height, right? So that would be 3 dimensions. So we would have to take the cube root of 64, giving us 3. This gets on into our powers of 3 in 15 and 16. Excuse me, powers of 3 or cube rooting. So again, just what number times itself would make 125. That's 5. Cube root of 27 is 3. Cube rooting negatives is always going to come out to be negative because we're working with an odd amount of numbers. So negative, negative, negative is going to stay negative. So that's why negative 10 is our answer there. And the root of 1 is always going to be 1 regardless of what root. Working with our decimals and our fractions, same rules we talked about above with square roots, just now with cube roots. So make it into a fraction. So 1/1000th, right? We can cube root both of those. You can work your way through the rest of those. Our scientific notation questions caught a couple people. Just double check counting your spaces. So 3, 6, 7, 8 to get the decimal right between the 4 and the 5. And here we're going to have to go backwards. We're going to have to go to the left to get back to the original value. So that's why our power is going to be negative. Writing these back in standard notation, if we bump the decimal to the left 3 places, we end up with 2 extra zeros. If we bump the decimal to the right 8 places, we end up with 473,500,000. And fixing the ones in 18 that are not in scientific notation, D can count as scientific notation, but because it's missing the decimal, we really would rather write it with the decimal, so 5.0 times 10 to the 8th would be better. So there's your quick review on Chapter 1. Please go ahead and do the Progressing to Mastery. Come get help if you need, but I would really like you to try that on your own. Do the best that you can, and then we will talk about your answers there. Thank you guys very much. Keep the questions coming. Use the community help doc. I'm here to help you in any way that I can.